We're good. Excellent. Okay, so I just handed you a bunch of stuff. Yay. Good. Very good, very good. So the formal title of what we're about to begin. We've done, if you will, four large topics so far in this course, all of which are interrelated. We've looked at estimating population proportions, and we've looked at estimating population means. Estimating little p, estimating little mu. And we spent a lot of time doing that. It's a lot of time doing that. What we started to do about a week ago was to bring in a new idea. Not so much just estimation, but trying to see if an interval has significantly changed because of some factor that we've applied to it. So for example, one thing you can do is you can estimate how many people have seasonal allergies over the course of let's do a real quick study right now. Who has seasonal allergies? There we go. I estimate that 60% plus or minus 12% have seasonal allergies. Boom. There's a quick, fictitiously made up confidence interval for p hat. Convenient sample, mental mathematics, every possible mistake you can make in statistics done right there by me. So 60% plus or minus 12% have seasonal allergies. There we go. Done. What should we invent since so many of us, at least in our little sample, have seasonal allergies? What should we invent? What should we invent? An allergy pill that's over the counter that actually works well, yes? How many of you guys use over the counter allergy medicines? How many of you have tried them but they don't work for you? Yeah, see, that's me. That's me. Claritin doesn't work, Zyrtec doesn't work, the other one, Allegra, doesn't work. Shots gave me a systemic reaction. I can't do shots either. One thing works for me, and you guys know what it is. Acupuncture is the only thing that works for me. And I know it's a placebo effect. Some of you say it, that's fine, I don't care, it works for me. Sorry, not to be selfish. So maybe what we want to do is develop an over-the-counter medicine that works as well as a prescription. The prescription medicines tend to be a little more power. They seem to work a little better. When I was getting allergy shots, they gave me some freebies. Some freebie pills that were prescription, they were samples. And they actually knocked the allergy right out of me, which was amazing. I don't know what the hell was in them. Probably nothing good. So we want to invent an over-the-counter that works. So how can we show that it works? How do we show that it works? Studies. Give me more studies. What are we going to show? In our study? We're going to do a study. We're going to do our study.
We're going to utilize a control group.
Control group, what do they get?
Placebo.
Placebo or one of the existing medicines already, which we can call placebo, yes. What does the experimental group get? New pill, right? New pill, experimental pill, yes. What are we trying to see? What define work?
Change. And it takes your
define change.
Takes your symptoms away.
Oh, okay. That's one way to do it. That is one way to do it. I really have no problem with that, actually, as long as the symptom taking away is well defined. See, and the reason I bring this up is I can suffer pretty well. Like, I'm one of those guys that likes running up mountains and riding up and over Mackenzie Pass and back. Like, I can suffer and it's like kind of enjoyable. It's a disease. So measuring symptoms often becomes one of those sliding scale kinds of things, right? So the trick is, if you can measure them properly, yes, I totally see. I was thinking of something simpler. Percentage of effectiveness. 60% of you say you suffer from seasonal allergies. Let's say with or without Claritin, right? Let's give you my new drug and see if the experimental group has a significantly lower incidence of the same symptoms. Measured properly, of course, Danielle, yes. So rather than just measuring the symptoms, just measure the fact if you're seeing the symptoms or not. 1 or 0 versus a sliding scale. Which again has to be well defined. I'm not saying it doesn't. So you see, the idea is you build a confidence interval around the normal control group, those who have allergy symptoms. You build the control group around those. And if you make a drug that works, where should your data fall with respect to the old interval? Where should it fall? If it's working. Say, nice and loud, Veronica.
To the left.
It's going to fall. Good. I like the left because that's showing decrease of symptoms. If your drug works, it's going to be outside that interval. That's the whole point, right? That's, Blake, you were joking about it earlier, but that represents a
significant decrease.
Right, statistically significantly decreased, yes, and I agree it's wordy, but every one of those is important, right? Statistically significant is a fact. It means the intervals don't touch. So if you can drop your data out and it and its corresponding interval escape the other interval, that means they're different, and in this case lowered. So today we start learning how to actually measure that. Rather than just reading the reports of a study, what would the p-value be if we had a drug that works experimentally?
Less than 5%.
Remember that from yesterday? I say yesterday, I mean Tuesday. If the drug works, you're going to read about it in a journal. The FDA is going to do a study. They're going to publish it. They're going to name it. Gonna cut up Mikey Egra.
Cool.
Yes, and then after Mikey, he gets 5% of all profits.
Shoot.
Yeah. Mikey Egra, you're going to read about it, the FDA is going to test it, and the p-value comes back at less than 5%. Because less than 5% means we assume it's not going to do anything, but in fact it does do something quite effective, lowering those symptoms. Of course, the less than 5% really just means what? We should do what with the drug? Say it again, replicate it, do it again, test it again, test it again. The FDA usually does like 40 to 50,000 trials right off the bat, which essentially shrinks down the margin of error to, if you will, nil. So they do a pretty good job of that already. But good, we're going to take all those ideas and today add the steps. The 10-step plan is what you hold in front of you on that sheet. The sheet that you took 4 copies of. Notice there are 10 steps on it. I think I numbered them. Yes, 1 through 10. The idea is, let me look over Daniel's shoulder here for a second. Step 8 is the one that the research articles gave us on Tuesday and last Thursday. P is less than 5%, please. P is greater than 5%. P is less than 1 in 1,000 was when we saw on Tuesday. The article jumps right to that. What you're going to learn, start learning today, and we're going to continue learning the rest of the term, is where that number comes from. What did they do to the data to get that number? Yes, that's the point. That's the point. So we're going to start with some data I collected. We're going to start with some data I collected. Is a flu vaccine working? Would you guys be so kind? Now you're going to need your data sheet. I apologize for these crappy copies. They start to look like crap down here. Man, that sucks. So grab your data sheet now. The 4-page, all the pages are different. You got this, you're
You'll
good.
need this one. You'll need 4 of these.
And read, it's only a couple sentences. It says single proportion testing, suppose 12% of people. Read it. Check it out. Austin, you need that? Oh, you got that. You need the templates. Yes, grab the templates.